exact area, and this is used in the method of integration by partial fraction decomposition. In other words, we're given this integral, which is 6 over u times u plus 2, all from 1 to e, and we need to realize that we can partition this fraction into a over u and b over u plus 2. And now all we have to do is work out the values a and b and then integrate these simple fractions, which will give you logs. So let's go ahead and do this, yeah? So let's say, let's solve this. So we're going to have a fraction of 6 over u times u, 6 over u times u plus 2, which is equal to a over u plus b over u plus 2. Now, if we were to multiply everything by u and u plus 2, this first term will cancel the u, and then we're going to have u plus 2 attached to the a. So let's have, so we're going to have 6 equal a times u plus 2. As for b, if you multiply everything by u and u plus 2, the u plus 2's are cancelled and you're left with just a u, so it'll be b u. Now to calculate these values a and b, we just need to substitute some values for u to get to eliminate it. So let's let u equal 0 firstly. What happens? We're going to have 6 equals a times 0 plus 2, which will just simply give us 2a. Let me just write it down quickly. So 2a, and then when you plug in u equals 0 for b, this will just become 0, so you're left with 6 equals 2a, and therefore a must equal 3. Easy stuff. Now same thing applies here, so let another value for u, so now we're trying to find the value of b. So let's say u equal minus 2, so then this part will cancel out. So when u equals negative 2, we're going to have 6 equals a times 0, which is 0, and then plus b times negative 2, so that'll be minus 2b. And likewise, b here would equal minus 3. Easy stuff. And that means now our new integral is going to be the integral of, so replace a with 3, so 3 over u minus 3 over u plus 2. All respect to u, and this is from 1 to e. Alright. Another cool thing is that we can just literally take out the u right now. The 3 right now, so we're going to have 3 and then the integral of e to 1 to e, and we're going to have 1 over u minus 1 over u plus 2 du. Now this is just simple evaluation, so let's plug in. So every time we want to evaluate this fractional term, this will just give us the log of u. So we're going to have firstly the log of u minus, and then this term here will also give us the log of u plus 2. And this is from 1 to e. Just to make a quick note why this is log u plus 2, the key idea is to differentiate the bottom term, realize you get 1. So you stick 1 outside, and then you smash it over into a log. And that's what we just did, is to be log u plus 2. So, last thing to do. Now all you do is plug in the values for e and 1. So let's do it in 2 parts. When we plug in the values for e, what do we get? I'll do it like this. So you're going to have log ln e, so this will give us 1. And put e here, we're going to have ln e plus 2. So we're going to have 1 minus ln. You can't actually do it, it's too tight. Let me do underneath. So you're going to have 3 times. So over here, we're going to have 1 minus ln e plus 2. Now, the last term, so we're going to subtract again, so we put 1. If you put 1 for the ln, you're going to have ln 1, which is 0, minus, and put 1 over here, we're going to have log 2. So ln 2. And that's it, guys. Now all you do is tidy this up, and then you'll realize that if you're going to tidy this up neatly, you got 0 minus this term, so this will be a positive log 2, so it'll be 1 minus ln e plus 2 plus log 2, and simplifying all of it neatly, you should get 1 plus, let's see, log 2 over e plus 2. So log 2 over e plus 2.